Okay, so this is a title of the first part of the title of a book that's coming out next year. And for economists, I would usually add a subcomment like,
oh.
Okay. I did what you told me. I just pushed page down.
I think you're on the side, right.
This is sideways.
Oh, okay. Should I go page up again?
Oh, yeah.
Go back to
Is
No,
the content is really, really good. Okay, okay.
Push the next. Oh.
Okay, she did it, I didn't.
Is this your take on tabula rasa?
Exactly. Okay, so
Arrow down.
arrow down and arrow up.
Yeah.
Okay, but I will have to correct errors as I go. So it's economics without preferences, but you're going to see preferences throughout this talk. So it's really not all of the preferences that economists usually imagine that people have. So let me talk a little bit about the prehistory of economics. So, and what exactly rationality is. So economics starts in the 19th century, which is really quite stunningly old for a social science. And as I'm sure you all know, economics started off by imagining that to be rational is to pursue pleasure, to maximize the amount of pleasure you can get, and this is a problem. So we're not getting all of the symbols here. So that's supposed to be the real numbers. If this problem gets more serious,
We do have a like.
exactly. Well, I could fill in occasional symbols as I.
You can also just draw directly on the TV if you want.
Okay. Once upon a time, economics said the rational thing to do is to maximize pleasure, and you modeled that with a utility function that maps a set of options onto the real numbers. And that was once upon a time the way that economists and other people, philosophers, started to imagine you would describe an agent. And as soon as economists said this, they were embarrassed by it. These people don't maximize pleasure. If they maximize something, they don't maximize anything that you would want to interpret as pleasure. And they stuck with the functions for a while, but they said, we don't really mean this. We don't really want to interpret this as pleasure. It's whatever goals people have. And it took quite a while, decades, because economists had to talk to others who knew about other formalisms. It wasn't until the mid-early 20th century that economists stumbled across binary relations, preference relations, as the improvement. Okay, I push the down arrow.
Okay.
Maybe this is. Okay.
Maybe you take it out of presentation.
Can I have the USB again?
Sure.
I'm sorry.
Is there? Have you?
Maybe I lost it.
About interpretive dance in the presentation.
Sorry, say it again?
Are you sure? Have you written the book already? Or? Oh, that's a nice.
I haven't seen the page proofs, so it's not really real until you see the page proofs.
Right.
Maybe it didn't.
I didn't do the safety of going towards the end and back again. But if you put it on the desktop, that really should have solved the problem.
Does anybody know anything about computers? Yeah, Alexander.
It's very, very odd it would get one slide.
So maybe this is your next slide. But Pareto tries to save this. Isn't that before the 30s already that Pareto was trying to save the real numbers?
Say it again?
You have to speak up.
Isn't this before the 30s that Pareto was trying to save the real numbers already?
Trying to save the
Real numbers.
Like real value utilities.
Yeah.
Sorry, Pareto used real valued functions as well. He had some, yes.
Pareto defends real value functions.
He invents real value
No,
functions?
defends them.
Defends them, yes.
They need them.
Well, they would defend the only form, and this is generally good advice in a profession, defend the only formalism you have until you have a replacement.
Because this one doesn't even have the...
Do you have another place to download the slides from now?
Yeah, you can go to my website. So Google me and click on the first thing you hit. Do you know my name? Mandler.
With an L, yeah. There we go.
Okay, go there.
Nice, very good.
Okay, then go to the add on to the stuff that's there. Go to the place where you type the URL.
Oh, I see.
Okay, and don't delete anything. Add ewp.slides.pdf.
Wow.
Hold it. Scroll down.
Yeah, exactly. Don't leave. Okay, but that's not good enough. I want to be able to go down page by page.
Yeah.
Can you download that and put it onto the desktop?
Well, you can full screen it, so it's like have 5 representatives.
Well,
In my experience,
And then I think.
Don't worry, the whole schedule is
Press
completely
the right and
imagined.
left arrow.
But
sorry, what?
Michael, but
Press
there's
the
one
right and
thing.
left arrows.
If you could repeat questions.
Right to
and
go down.
comments,
Yeah.
because for the audio, for the.
this and this.
Okay.
Down is right.
Down? I thought you were pushing the right.
Press right. Next slide is right.
Okay. Someone asked about Pareto and real valued functions. I'm not exactly sure what the question was. But in any event, people defended the formalism until they had a replacement. And that's always the pattern in academic disciplines. You can whine and whine and whine. The complaints have no traction until you can replace it with something better. And I'll give you an example of that pattern later on. So people like Pareto said, oh, we don't mean people are maximizing pleasure. Actually, he was a bit retrograde on this question. But people in general said, we're not assuming that people maximize pleasure. We're just, in a more modern terminology, they would say we're just representing their behavior via a real valued function. But they didn't really get precise. What I just said really didn't start to be said until the 1930s. Okay. So this was the punchline of it took 10 to 20 years before economists could come up with something this concise. So it started in the early 30s. It wasn't until the early 50s that economists said, what we really want is to start off with a binary relation on this set of options X, and it has 2 properties which I'm going to summarize with the label classical rationality. So you know what these are: completeness and transitivity. You can compare anything, and if X is better than Y and Y is better than Z, then X is better than Z. Now, I just want to make why have I gone through this prehistory? I want to make one comment about the prehistory, is that if you do start by assuming that people are little pleasure machines, so you take as you don't do this, instead you do the 19th century thing of taking as primitive their utility function, then obviously you can you can define a preference relation from the utility function in the obvious way, that X is better than Y if its utility number is at least as big as the utility number of Y. So that obviously, because you're going to be assigning a number to every option, binary relation that you're defining is obviously going to be complete and transitive, because numbers are transitively ordered. Why am I making that observation? It's that the reason why classical rationality defeated its predecessor theory is that it could make a reasonable claim that it was being more general. If you begin with utility functions, you're going to end up believing in a complete and transitive binary relation, but you're not wedded to that particular account of why preference relations should be complete and transitive, or classically rational, as I'll call it. So you don't have to be a hedonist. The reason why this is interesting for economics is that this claim of generality was devastating to the old utility school, and they subsequently died, often quite literally. So they were dead and buried quite rapidly, and it's amazing how pathetic their responses were. And they never made what I think would have been the crucial objection to this revolution in economics, which is, well, okay, maybe this is more general, but if you're giving up wholesale on the idea that people are pleasure maximizers, why is it that they should have complete and transitive preferences? So we know that a hedonist who starts off with this utility function will have complete and transitive preferences, but why, if you're not a hedonist, why should you have complete and transitive preferences? So the detour is to make a distinction, and this is the most important thing I'm going to say, between preference theories where you're talking about agents who can look at the various ways of aggregating goods, look at all the goods in the world, and they can come up with a unified way of creating a ranking, and those who can't do that. And keeping in mind that distinction, this is what makes preference theory interesting in my view, keeping that distinction in mind, I think, is the key to all clear-headed thinking about a huge range of subjects in economics. So, and the reason why I'm bringing this up for this audience, I think it's an interesting point anyway, but the reason I'm bringing it up for this audience is that if I was thinking for at least a few minutes prior to coming to this talk, what is the subject matter I'm going to pursue are agents who fail to have a unified goal in this sense, who can't make all these rankings. But when agents do have a unified goal, then it is easy, just as it was for the hedonists, to come up with an argument for why their preference relations should be classically rational. So if you write a program for a machine that does a task like predicting the next word in a sentence, then you're in the earlier camp of preference theory. You're in the 19th century hedonist camp because you're specifying a unified goal, and you're judging everything by how accurately can I predict the next word in a sentence. So the thing that makes people interesting, in my view, is that let me finish my sentence. The thing that makes people interesting, in my view, is that they might deviate from that rule. So this might be an interesting distinction between people and machines. Go ahead, whoever that was.
It's not exactly the 19th century hedonist because it's not specifically pleasure. It could be any function, right? So
That's exactly my point, is that you could replace pleasure with some other thing that you're maximizing, but it is a way of unifying all the options you have to choose from under one criterion. So it's obviously machine, the predicting the next sentence is not a goal like pleasure at all. The point is that it is a unified goal. Yeah?
I think I should log the standard objection that the objective used to train a machine learning model is not necessarily the same as like the objective that that model then pursues in its behavior.
Yeah.
Yeah.
Well, it's obeying some criterion for its updating. So whatever that criterion is.
It's obeying some criterion for its updating. And
Yeah.
It's obeying some other criterion for its action later.
Okay, well, we would deal separately with these. I don't know what the action is, but at this point we're
This output for an LLM would be the action, like
the prediction of the word.
Where's the-
Yeah. Well, you can evaluate your success. So I'll amend this. If you impose a criterion to evaluate the success of your predictions, maybe not the probability that you've, maybe not maximizing the probability of getting the right word, maybe some other criterion, insofar as you're specifying such a criterion, then you're falling into the first camp. And therefore, you're different from what I'm going to describe.
But we don't have such a thing for modern AI. We only have.
That's not what I said. I said insofar as you're specifying a criterion for whether you think you've done whether this prediction is being done well or poorly, then you are falling into the first camp. Okay. Insofar as and the more general principle is that insofar as you specify one of these global criteria, then you're falling into the first camp, not the second camp, which is the main subject of this talk. Can't remember, is it right?
Yeah.
Okay. So the thing I'm heading for, and there'll be some detours along the way, but I want to give you a picture of where we're going, is here is an agent who's who doesn't have unified goals. Here are two indifference curves for two different preference relations, and this agent, in the face of these conflicting advice of these two different preferences, follows a unanimity rule, that you only declare something better than X if both of these preferences say it's better, and you only say something is worse if both preferences say it's worse, and the stuff left over, which looks somewhat like a bow tie, is unranked. So
whoa. How am I going to operationalize this whole unranked thing?
I have no idea.
Just verbally ask them, do you have a preference between these two, and they say no, or what? What are we doing here?
Yeah, well, that's going to be outside of the confines of this talk. So, there are good, well, I'll touch on it to a small extent in a few minutes. Yeah, did you want to say something?
It was already covered.
Okay, very good. Well, when I get to choice functions, we'll see if that appeals to you. Okay, now I screwed up.
Yeah, I do right.
Okay, so this is the outline of where I want to go. The shorter answer is whoever claimed I was trying to do something that is operationalizable You can't even, can you see the little gray thing? I covered topic number 1, which is what is rationality. And there's a whole bunch of stuff here. I can't possibly get to it all. I usually have in my mind, some goal I'm heading for where I declare victory, and I think it's between 3 and 4. So I'm going to look at arguments in favor of classical rationality. Maybe you'll find them convincing. Then I'll look at arguments against. And then once I've convinced you that the case against is really the stronger case, then there's this long list of applications to various things in economics. And we'll see if we get to any of them.
If you're
Can you-
complete in time, drink coffee until it does.
I didn't hear that.
That's good, keep going.
Okay.
Can I ask you to skip through the 2 and 3?
No.
To go to 4?
No.
Oh.
No. 2 and 3 are more important than 4 and onwards, and you won't know what the status of 4 onwards. So that I'm not going to do. I don't know what any of these things on that list have to do with agency, alignment. I don't know what the word agency means. So a certain amount of trepidation in talking at a conference where I don't know a good chunk of the words in the title of the conference. But I will proceed anyway.
You're in good company.
Okay, very good. So what is the case for classical rationality? If you have preference, if you think of preference as people intuitively do, is a judgment, an agent's judgments of their own welfare or their well-being or what they like more, something like that, there are sound money pump arguments for why those preferences should be transitive. Most of you, I think, are familiar with those arguments. I think the crucial question is, why should those judgments of well-being or welfare be complete? And the standard answer in economics, and it is of interest to me that people are rarely explicit about this, but it is part of the oral tradition in economics that you know this answer. The standard answer in economics is that in order to elicit a judgment of whether you think X is better for you or Y is better for you, is you make someone choose. So you have to choose one or the other or we'll shoot you. And you see, it's astonishingly rare for someone to then say, if we use that forced choice definition of what it means to prefer something, are you going to undermine the money pump case for transitivity? And that seems to be the most important question in preference theory, is exactly that one. So what's the bottom line is you need to make a joint case for completeness and transitivity. You can't divide and conquer. You can't say, you have these transitive judgments about well-being, otherwise we'll money pump you, and over here, I'm going to force you to choose. You have to unify these in one account. So you can't do that with preferences, and I've had discussions with a couple people already today about why you can't do that if you restrict your formal vocabulary just to preference relations, just to these binary relations. You need an alternative formalism, which in economics are called choice functions, which are very different from what a mathematician calls a choice function. So what is a choice function? It's defined on a domain of non-empty choice sets of alternatives. So they're subsets of the grand domain of all possible options. And it specifies for every subset, every choice set in this domain, a non-empty subset that you interpret as what the agent deems to be an acceptable choice. It's a set. You can choose more than one thing. I'll assume this includes this domain D includes all the pairs. You wouldn't want this to be all possible subsets, because on an infinite subset of things, you might not have, intuitively speaking, a most preferred item. So you need to appropriately restrict the domain in intelligent ways. Once you have that as primitive, you then define a preference relation from that. And the standard way to do that, these are called revealed preference relations, so R for revealed. Is that you say that X is revealed preferred, and I hate this expression, but it's that we say that in this cumbersome way. We say that X is revealed preferred to Y if there's some choice set in the domain such that Y is available, but you choose X. So you're revealing that you like X more than Y, because you could have chosen Y instead, or you could have, it could be that you could choose both. This would then qualify. Okay, so that repeats the same thing. So this, because I said we include all the pairs, this R, this revealed preference relation, has to be complete because I give you X and Y. The rules of the game, we shoot you if you don't choose, or you get 0 consumption or something like that. You've got to choose at least X or Y or both. So now the question is, the whole question comes down to why should R be transitive? So look, I'm going to give you, this is still the case in favor of classical rationality, so I'm playing devil's advocate. I'm going to give you the best case that can be provided. So I need some terminology. P, this is P for prefer, is the strict part of R. So if X, P, Y, that means X, R, Y, but not the reverse. So what does that mean? That means you never choose Y when X is available. And at least on one occasion, you choose X when Y is available, because in that case, you choose X from the set X, Y. And you interpret that, you have to, in order to come up to make any sensible argument, you have to endow P with a welfare, well-being interpretation, is that if you never choose Y when X is available, then you do think you're better off with X than with Y. Or you so strictly prefer, P for prefer. Okay, so now we can talk about whether this R should be transitive or not. And we're going to do this by confronting the agent with a sequence of choice sets. So the first choice set is going to be A1, then it's followed by A2. And for now, I'm just going to stick with 2 choice sets, one followed by the other. So suppose if I give you choice set A1, you can hold on to one of the items that you choose. So you choose C of A1 from A1, and one of those items is going to be held on to set A2, right? So A2 intersects C of A1 is not empty. So implicitly, whatever you chose, you could then hold on. You don't need to say that you don't need to formalize exactly that requirement. Okay, so what does it mean to be manipulated? It means, in addition to the choice sets being linked in this way, so what you choose at A1 is intersecting with A2. In addition to that, if there's something that you choose, if there's something available in the first choice set, Z, you choose X from A2, and you prefer Z to X, we conclude you're manipulated. So this is a version of the money pump. And you're manipulation free if that never arises. Okay? So these choices can be very complicated objects. So these can be lotteries. So they can be, you're including some of the money pumps that you may have seen in other settings. Being manipulation free is going to imply immunity to many types of money pumps. So now we're getting what we were aiming for. So we're near the conclusion of the case in favor of classical rationality. If you take a choice function that's manipulation free, then its revealed preference relation is both complete and transitive. You've already seen the argument for why it's complete, so suppose it's not transitive. So what then has to be the case? There has to be an X, Y, and Z in the set of options such that X is better than Y, revealed preferred to Y is revealed preferred to Z, and not X revealed preferred to Z. But since R is complete, that implies that, that means that since not X, R, Y, that implies that Z actually has to be revealed preferred, strictly preferred to X. And I think that does it. Due to the fact that Y, R, Z, we can construct an A1 where Z is available and you choose Y, and we can construct an A2 where Y is available and you choose X, and since, by assumption, Z is preferred to X, you're manipulated. So that, I think, is the case. So the apparent moral of the story is that whatever's going on in your head, you have to act, if you're self-interested, you have to at least act as if you obey these 2 axioms of classical rationality. Okay, so this is the first time we can have a pause, and I'll move on to the case against.
It wasn't quite clear to me why you moved to the choice functions. What exactly is the benefit compared to just having a relation?
Well, I don't know how, it's not just a choice function, but you have to confront people with a sequence of choice sets. I don't know how to make the joint case for completeness and transitivity unless I begin with the choice functions.
Okay, yeah.
Because otherwise there's no argument for completeness. So I understand making the transitivity argument. I don't think it's the best way to pose the matter. I understand making the transitivity argument just using the binary relation as raw material, but I don't understand the joint case. Okay, now that we seem to have come to this sweeping conclusion. Yeah.
I was wondering if we can make a more pragmatic argument on the pro case, in that utility function preference orderings that satisfy this are incredibly useful. They're very easy to work with, and so then it's like, okay, I would like them to be completely transitive, and I know that maybe they aren't in places. But then it's like, okay, so if you go to test code and you're not really actually complete, you can't use the things that are actually incomparable, but I still managed to buy something going.
Yeah.
Okay, maybe I'm then like computation.
But the question is, are you compelled to use such a thing? So indeed, it may be one convenient way to choose, maybe what you described. Are there other ways to choose that are also completely self-interested? And we will see momentarily, but you've got to wait, that it's, I think, on the same order of complexity, the same order of simplicity, I should say, as using a complete and transitive preference. So I will come to that point and I hope to make the connection. Hope I don't forget to make the connection. So now let's talk about the case against, and again, following the case against, or as part of the case against, we'll see that we'll have a very, very simple rule where your revealed preferences will fail to be transitive, they have to be complete, where your revealed preferences fail to be transitive, yet you are doing something just as simple as your Tesco shopper. Okay, so indeed we're practically here already. So suppose you can't decide whether X or Y is better. These are two options. You might, if you can't decide which is better, and I think this is simple, you might, if you begin, these two options are X and Y, if you begin with option X and you don't know how to rank X and Y, you might say, well, I'll just stick with X. However, if you begin with Y and you still don't know how to rank X and Y, you might say, okay, then I'll stick with Y. So that strikes me as just as simple, and indeed it better describes my shopping experience, is I don't go around optimizing. I just do unless I have a reason to deviate, I do what I did last time. So I think on the simplicity contest, completeness and transitivity is actually the more challenging thing. You have to invent this giant preference relation over everything you could conceivably buy. So I think it's a myth that actually that is the simpler way to proceed. For my purposes, for talking about whether an agent is rational or not, the problem with the case in favor of classical rationality is that if you believe the middle paragraph here of being governed by status quo bias when you can't decide, when you can't figure out how to rank two things, is that there's no obvious way to define what you should, there's no obvious way to define a single choice set, which is what you choose from the pair X, Y. It depends on what's the status quo. So we have to eliminate, or better enrich this framework, and this is what I'm going to call a sequential choice function. It's going to look complicated, but so you've asked the best question so far. It's going to look complicated, but in fact it isn't. Those questions over there, they were not really up to snuff. Okay, so a choice function is actually going to be a family of functions. It's going to be what you choose at every time t. The t is going to be the positive integers. And it can in principle, although it will not have to be, it can in principle be a function of these sequence of choice sets. So you do the same thing, so it's this entire family is a sequential choice function. And once again, you have to specify a non-empty set of the final choice set in this sequence. What, you're saying something about the time? We're at the halfway point?
Yes, somewhat close.
Well, we should have stopped a few minutes ago. When I said we're pausing now, you should have said, okay, anyone can leave.
Soon, you can decide.
I have a question.
Anyone can leave anytime they want, yeah.
So it seems to me that, like, you're positing that the status quo bias is in some sense, like, in some strong sense, a representation of the preferences.
No, not a representation, it's a behavior.
Okay, but you're kind of using that as an argument for why we should like think of preferences in some particular way, because we want to have the status quo bias as part of our model.
No. I'm just saying, intuitively, when you can't decide between X and Y, one plausible behavior is you stick to something until you see an argument to switch. That's all I'm saying.
But that's completely consistent, I think, with classical theories of preferences. You could just say, well...
Okay, I'm gonna pause this for a second.
Yeah.
And declare that the 5-minute break is now.
Well, we can continue this so I don't think we want to spend too much time on this point, so it's excellent for the break.
Are dismissed.
Yeah, I'm going to find the goal in 4 minutes.
The short answer is you want to give people the flexibility to do something different if they're endowed with X to begin with versus they're endowed to Y to begin with. The standard framework of choice functions that I gave you stops you from doing that.
I'm not sure it stops you from doing that, because you can argue that there's also, and the reason it kind of stops you from doing that is because...
Formally, it stops you from doing that. You have to specify one set for C of X, Y.
Yeah, but that's because you're not thinking about efficiency at all. Like, you're imagining that the agent that's making choices has like unlimited resources to make the choice. Like, the real reason, when I come into...
You're not talking about the same subject. You are prohibited. You have to choose one choice set. You have to choose one set of options from X, Y for all time in that previous framework. That's a mathematical requirement of the framework. I think it's unreasonable. What's your objection?
So my objection is that given the classical framework, if on top of the classical framework we also add the consideration that real-world agents also
the classical framework I'm dealing with is choice functions.
Yeah.
Okay,
I mean,
so...
I'm just thinking of like V&M utility theory.
No, I'm not dealing with that. I'm dealing with choice functions. So if you don't deal with choice functions, you're not going to be able to make the joint case for completeness and transitivity. That was the argument for why we had to go to choice functions. So I don't know what you're talking about.
I don't really... I mean, the thing I'm talking about is, are actual agents modeled well by V&M theory, for example? Choice functions are just a special case of it. Or do we need, like you're claiming, a different type of...
Yeah, if you can't rank things, why should we require you to always choose the same thing every time you confront this choice set?
I'm just saying that...
No, answer my question. Why should we require you in the foundations of the formalism, why should we require you to always choose the same thing from X, Y if you can't rank them?
Why should we require you? Well, I mean, what is the word should doing this? We need to delve in what does it mean should require? Like, what is the goal?
If you want to evaluate this agent's rationality, do we want to say, as a requirement of rationality, you always have to choose the same thing? That makes no sense to me.
Yes, because you can never put the agent in the same situation twice.
Yeah, if you follow that argument, the entire thing is useless.
I think the entire thing's not useless, even with that.
So does someone know how to solve this?
I mean, you're thinking of it in terms of like
simpler.
axiomatically deriving the theory of rationality from some small number of assumptions. Whereas I'm thinking about, I'm not convinced that like...
I want to make an argument for whether it's not that complicated. I want to say, is this claim that I laid out for you, it's the only way I know how to argue for classical rationality. Does this hold up as soon as you grant agents permission to do different things at different points in time?
I think that there's a different way to argue for classical rationality. And the way to argue is to say that we have already a whole body of theory.
A what?
A whole body of rich theory on top of classical rationality. Like all sorts of, planning theory and learning theory and control theory. And
so I don't understand why that's an argument in favor of it. So there's a lot of academic work. I'm sorry.
Like saying that you built a whole bunch of stuff on top of CFC. What are you doing studying alternate set theories? I
think that the value of a theory is holistic. If a theory produces a rich number of conclusions that seem to be relevant and useful in the real world, then that's a good theory. I don't think
sorry, I did not mean to claim that this theory is that the theory of classical rationality is completely useless. I'm simply asking, is it a requirement of being a rational person?
I mean, that's kind of a philosophical question.
Yes.
What does it mean to be rational? Right.
Well, for this talk, I'm taking it as given that it means those two assumptions, completeness and transitivity. So if you disagree with that, then there's no point in going further. But if we take that as given, then I tried to construct in point 2, the only argument I know for why both properties have to hold simultaneously.
Okay, but it also feels like you're trying to argue, to imply that your point of view is a better explanation.
No, I'm simply asking, is the case for rationality sound, for both those properties of rationality? That's all I'm doing.
Okay.
Okay. Sorry?
You know the trembling argument?
The trembling? Trembling. Yeah, sort of. You're going to have to remind me of what it is.
This is the one saying that if we have like incomplete preferences in the sense that you're setting up here, then you can get a Pareto improvement by completing them.
Right, let's just have one person. So let's just have one person, so the Pareto issue doesn't come up.
Pareto improvement because by having incomplete preferences, you can represent that as a set of complete preferences.
Right, so I think that's a false claim.
Okay.
Did someone say you can talk again?
I think Alexander will do that.
Okay, you can usurp him.
Actually, I'm just going to.
Okay, fine, very good. I think we've agreed that this is one question that one could ask, is whether the case I presented to you for the rationality of completeness and transitivity is a sound one. So what I'm doing now is letting people vary their choices depending on the sequence of choice sets they've faced. And I call the collection of these functions, I call the entire collection a sequential choice function. And you define reveal preference relations in a similar way. I put a hat over it to indicate that it's now in the sequential setting. So if there's some sequence of choice sets where such that the final choice set in the sequence contains y, but you choose x, then you've revealed a preference, a weak preference for x over y, and you define the strict part in just the way as before. So I'm skipping some minor details. So you define, you probably don't want to read the stuff in the bottom half because it's a completely straightforward translation of what's in the top half. So a sequential choice function is manipulation free if there does not exist a sequence of choice sets such that such that x hat is available at the first state, you choose xt at the last state, you prefer x bar to xt, according to p hat, and every pair of periods is linked in the way they were before, that what you choose at time t is available to be chosen at time t plus 1. So if you can do all of that, if you cannot manipulate someone in that way, then you're manipulation free.
So if I have a binary choice and I want to like alternate between two things because I like variety, this is irrational according to this?
Yeah, you only consume once, so you're not actually consuming it every day. So these are trades. This is a very good question. You have to get out of the way.
Can you repeat the question?
Thank you, which you told me to do. So the question is, if you tell me if I'm repeating it correctly, if you want to switch back and forth between consuming X and consuming Y, would you then be manipulated by this sense? And the thing I didn't say, which I should have said, is that these are all trades that you make prior to consumption. A1, so these are a sequence of offers that you get. Would you like to switch to this? Would you like to switch to that? Can you lead someone through such a sequence to something that they dislike relative to what they started with? Yes?
Well, now I think this is a really weird model, because you motivated it by saying that, like, well, I'm in Tesco, I choose what I chose yesterday. But, like, actually, this isn't like you get to choose what you chose yesterday.
Because it was an answer to a different question. I don't think I have time to repeat all the questions. So this would be These are the sequence of markets that you go to, so to speak, before you finish your day's shopping. Or someone comes up to you with various offers, but it is just what you're consuming for dinner tonight. So it was an answer to a different question. Okay, so maybe just a trivial example. So in this example, there are just three things. Y prime you actually strictly prefer, psychologically speaking, in this welfare sense. Y prime is better than Y. You make no other judgments. Okay, so what should you do if you ever face a choice set that has both Y and Y prime? Don't choose Y. Other than that, except for that restriction, you can choose anything you want. So let's suppose when a choice set doesn't contain both Y and Y prime, you choose the entire set. So if you face X and Y prime, you say, okay, I can't rank those, I'll choose both. Then in the second period, you face X and Y, you say, okay, I can't rank them, I'll choose both. Then you're worse off because you could have stuck with Y prime the entire time, yet you declared Y to be acceptable, and therefore you might end up with that, yes?
Why is this a simpler or more interesting or more intuitive model of status quo bias than just having a standard utility function with some penalty term for changing?
Because I don't actually think that is the standard way of doing it, but if you were to introduce a utility function where there was a penalty to changing, you would be presupposing this large set of rankings. Here, all I am doing, I haven't defined what status quo maintenance is yet, but when I get it, but it's coming very shortly, when I define what status quo maintenance is, you don't need to make up all those things. You just need to say to yourself, are you offering me something better than my current holding? So I think that's simpler than what that's. Sorry?
It's a weaker requirement on the choice function.
It's.
I mean, I know
It's not. It is easy to construct the choice functions that obey the rule I just described. I think that would be my way. Easier than. Wait a slide. You'll see, I've written down what the answer to that question is. So once again, I'm fully sympathetic to the question. Okay, so what is status quo maintenance? Don't read the tangle of stuff at the bottom. It simply means two things. You never choose an undominated option. And when you're doing sequential choice and something is held over from the past into the present, you either remember, you can't choose an undominated option. You either choose the thing that's held over or something that dominates it. And domination is always with respect to p hat.
Hold on, did I miss the part where you told us what domination means in this context?
P hat.
P hat.
P hat, that's the strict revealed preference relation for this sequential setting. So it's p hat, you perhaps can't see at this angle. It's p hat undominated on the slide. So you use p hat to define domination. So never pick something that's p hat dominated by something else available. If something is held over, either choose it or something that p hat dominates it.
Okay, I'm pretty sure you've now set up enough machinery
Yes.
that if you have incompleteness here, then we can get an improvement, a p hat dominated improvement
Right.
by completing the preferences.
Right, so that's not correct. Okay, so here's the answer to your question. You'll see, it'll be a theorem. Status quo maintenance is easy to execute. All you have to do is think about what's the stuff currently available that was available at that was also chosen at the immediately preceding date. So you look at it, is there anything like that? You say to yourself, is there anything is there anything currently available that I chose in the immediately preceding period? If so, you say, I'll either take that or something that dominates it. And if that requirement isn't met, you don't have to do any hard work. You just pick something p hat undominated. Okay. So going back to this example, remember y prime has got an extra term. Therefore it's got an extra little marking on it. And therefore it's better than y. What was the problem with what our agent did? There wasn't a problem in choosing in saying in response to the first choice set that both x and y prime are acceptable. That's completely fine. The problem is in the next round. X is available in the next round. It's in A2, so you're only allowed to choose x or something that dominates x, and there is no such thing. So you're not dominated, you're not manipulated, and you don't actually need to make the world any more complicated to, I think, see that what you claimed earlier wasn't true. So the theorem is, if you take a sequential choice function that leads to a transitive p, maybe that's the point where we disagree. Okay, if you take a sequential choice function that leads to a transitive p and it's status quo maintaining, then the choice function is manipulation free. Furthermore, it's very easy to see that a status quo maintaining sequential choice function can lead to an intransitive, weak, revealed preference relation. And it may be that you're not used to being the thing that you're checking.
Nope, that's the thing I'm used to checking.
That is the thing you're used to checking. So you're just out and out wrong. So I was trying to save you. Just to refresh your memory, why do we care about the weak revealed preference relation? Because that's the only thing that we have a fighting chance to show might be both complete and transitive. Here is, I think this relates to what's your name?
Cecilia.
Cynthia?
Cecilia.
Cecilia. Cecilia's question from before, I think, is relevant here. Normal economists, who do things like data and worry about what can be implemented and things like that, operationalized, words that are very alien to me, they think that people who do status quo bias are examples of the real world irrationality. People choose in this arbitrary way, they stupidly stick with whatever they have, and this is a symptom of irrationality. And I'm saying the exact opposite. I'm saying that status quo bias is actually a clever way to avoid manipulation and is a sign of being a rational person. Unfortunately, we don't have any, normally I would make this remark to provoke the behavioral economists in the room, and there are none in the room. So there's no one here who's getting mad at me about this comment.
This is a ridiculous claim.
Yes, okay. Now you're my new favorite questioner.
There are clearly cases where status quo bias is. Are you defending all status quo?
No.
I mean,
I'm tempted to say yes just to get you to continue, but I don't believe that. Yeah, go ahead.
You don't have any uniqueness here. It's status quo works.
Oh,
so you can have anything else.
Yeah, but
as far as not anything else works, but you don't know what else you could have.
What other things would be manipulation free, you mean? Yeah. Or do you mean the fact that status quo bias may not identify a unique choice?
No, just what other...
Yeah, no, there could be other things that are... There could indeed be other things that are manipulation free. So I don't actually know the precise answer to your question. It's actually quite a good question. What is the entire family? I don't know the answer to that. Yeah.
So can you give an example of an intransitive preference that's rational according to your definition?
Yes, I think that's the next slide.
I hope so.
Okay, so this yada, yada, yada. Freedom from manipulation does not imply both parts of classical rationality. So I'm not sure this is the best interpretation of your question, which is, the way I'm interpreting your question is, show me the intransitivity that comes out of this. So you can always construct an intransitive weak revealed preference relation if you're a status quo maintainer. If you assume there's a triple of options, such that I'm keeping with the example as much as I can, such that y prime is strictly p hat superior to y, and there's something that's unranked both relative to y and to y prime, which I call x on that slide. So this is the sort of example, this is the sort of thing that happens when you don't know how to do the trade-off between x and y in a similar way to the pictures that I showed you near the beginning of this talk. So if you just want to confirm that if you're status quo maintaining, that this will indeed lead to an intransitive revealed preference relation, so you're interested in this as well, just consider this simple example. Suppose you consider that you first confront the agent with the choice set x, y. Those aren't ranked. Those aren't ranked. So you say, okay, both of them are acceptable. And in the second round, x, y in the first round, I give you x and y prime. So from that, because you're a status quo maintainer, you have to choose x, and that is now giving us an intransitivity. So from the first one, y is chosen when x is available, so y is revealed preferred to x. From the second one, X is revealed preferred to Y prime since you choose just X from the second choice set, yet transitivity plainly doesn't hold because we're assuming that Y prime P dominates Y.
Yeah, so this is exactly the argument that you could get an improvement according to the agent's original preference ordering by completing the preferences, adding a preference.
So, sorry, I'm incredulous. You're saying you're going to complete the preference and then judge the guy to be better off according to the thing you just made up?
Better off according to the original
No, okay,
preferences.
so you show me how to do this in this example.
Yeah, so what we're going to do is we're going to say, all right, I'm going to go to my agent who's being modeled by these original preferences. With,
Yeah, you just have one original preference. Y prime is better than Y.
From Y to Y prime.
You've got to show me a manipulate. You've got to show me how I'm going to lead this guy from Y prime to Y.
What I'm going to do is I'm going to offer this guy a contract. And this contract is going to say, if you sign this contract, we're going to flip.
Okay, so you're only allowed to offer people a list of options. If you want to have fancier contracts, then you're just going to have a long list of state contingent deliveries. So, but you ought to be, and in this world, I just have 3 options. But I promise you, this holds with an arbitrary family, big X, of options. So everything you've just described is in this framework.
I'm not, but this seems to be trying to handle complete contracts by pretending that the contracts don't mean the things they mean.
No. A contract is going to be a delivery at every state of nature. What else would a contract be?
Yeah, okay, I'm on board with that.
Okay, so I've this framework. This framework applies to. So if there are a finite number of states of nature, states of nature, then it'll be this. Framework applies, for example, it applies in fact to an arbitrary X, but it certainly applies to state contingent deliveries over, say, S states.
So the basic thing we need to do is this agent is going to pre-commit to accept trades from Y to X and trades from X back to Y prime.
Okay,
and then on net, they will expect to end
okay, so you're deviating from where we were going. You don't want to stick to this example, so we'd have to have the whole framework. Let's go to that at the end.
I think in the language of this example, the proposal is here's an alternative C that corresponds to complete preferences.
You've got to show me how this guy is going to be manipulated.
It's not a manipulation. That's not the claim. The claim is that they will do better according to the original preferences.
That's exactly what I mean by manipulation.
No, your claim in manipulation is that there's a money pump, as in.
No. You just end up with the worst thing.
No, you're willing to let them forego.
All right. No, we're cutting this off.
Do this in the
Yeah.
session.
Okay.
But
Okay, we're going to cut this off. Okay. Despite the disagreement from the peanut gallery, the project of showing that rational preferences have to be complete and transitive fails. It is, by the way, the case that you can show that p hat has to be transitive. So if you have a choice function that leads to p hat and it's manipulation free, then p hat has to be transitive.
I'm confused about what your choice functions mean. So your choice function is a function of the sequence of sets, right? And it outputs also a set.
The choices that you make, the choice function is the mapping.
Yeah, the choice function is a mapping
from these sequences to subsets of AT.
So what is the meaning of this sequence?
It's a set of offers that you are given in sequence. So here you can choose from A1, you choose something, and I say, okay, I'm going to pick some of those and put them into A2. Now you can choose something from A2 and so on.
But you don't have the information there of what you actually chose. It's like
Yes, what do you mean? It's C1 of A1 is what you chose from the first round. C2 of A1, A2 is what you choose from the second round.
But if it was a set, rather than just one element.
No, it's a set. It's a set.
Okay, but you cannot choose multiple things, right?
Well, because sometimes you say 2 things are okay.
But
You interpret the set as the things I'm willing to choose.
They're the set I think that are acceptable.
If you're talking about status quo bias, then shouldn't your future choices depend on what you actually chose out of the things that all...
You don't. Okay, if you want, you can say I'll only choose one. If that's how you want to be, if that's how you want to interpret status quo bias, there's no problem in saying you choose a singleton in every period. That's fine too. It's not relevant to this problem.
And your example with intransitivity, does it still exist if you always choose a singleton?
Oh, not this example, but you can start other examples where it would easily hold.
Is there some assumption I missed for like an plus 1 includes choice of a1 through an?
He said that.
Or a intersects?
I couldn't follow that.
Yes,
There's an
yes.
assumption I missed that an plus 1 intersects.
Yes. It always intersects. Sorry. In order to declare someone manipulated, it has to be that there's this chain where everything that you choose at least one of the things you choose at date t is passed on to the next choice set. Okay, I think interesting because I see this mistake being made is that people think that the argument for the transit that I'm defending the classical money pump in this theorem here. I can show you the proof. It's pretty trivial. But people nevertheless find it puzzling. I'm really defending at least one aspect of the classical money pump. I'm defending the idea that at least p hat does have to be transitive. And people sometimes get this muddled up. They say that argument presupposes that your judgments of your own welfare or well-being are complete, and nothing like that is true. So I'm not assuming anything that you can always compare every pair of objects. I'm just saying you have to choose. And by that standard, even with that weak requirement, you can conclude that p hat has to be transitive. So that's the proof. Okay, this is the point where I said I would declare victory if we got this far. I'm not paying much attention to the time. How much time do I have left? 10? Oh, boy. Okay. So let me just take a brief tour through a couple applications of incomplete preferences. So now, if you didn't like choice functions, and it's one of these dividing lines between economics and other subjects. On the rare, unfortunate occasions when economists and philosophers try to talk to each other, the philosophers react with hostility and anger to choice functions. If that's your training, you might have the same reaction. So we're now junking the choice functions. We're now returning to the bread and butter interpretation of a preference as I like X more than Y, or I think I'm better off with X than with Y. So the canonical case where incomplete preferences arise is when you have a whole bunch of conflicting preferences, which I call candidate preferences, and you say that you prefer X to Y by unanimity aggregation if every candidate preference says X is better than Y. So in economics, including state contingent deliveries of quantities of money, we usually deal with sets of options that are in finite dimensional Euclidean space. These things are called better than sets. When people use, sometimes they're called upper contour sets. These are for the candidate preferences, the set of Y's that are better than X according to the candidate preferences. The set of Y's that are better according to the unanimity aggregation is just the intersection of all of the better than sets of the candidate preferences, which is seen in this picture. So these are the two candidate preferences. The intersection of the two better than sets is everything to the northeast. This is like that original picture I showed you an hour ago. Everything to the northeast of X is judged to be better. I haven't included the worse than set as everything to the southeast, and the stuff in here is unranked. So that's the most interesting case of incomplete preferences. But what's important about it for economics, and here I think I might well start talking about stuff that you guys have absolutely no interest in which case you might start yawning. What is important for economics is not the story of unanimity aggregation. The important thing for economics is that kink, is that the better than set is not smooth in a neighborhood of X. It is kinked. And what do I mean by kinked? I mean a multiplicity of supporting hyperplanes. So these are the normal vectors to the hyperplanes that support the two candidate preferences. As mentioned before, the better than set of the unanimity aggregation is the intersection of the two better than sets of the candidate preferences. I'm going to take out the hyperplanes or lines because it's easier to read. And what I mean by kinked is that there's first of all, that the better than set of the unanimity aggregation preference is supported by a hyperplane with normal P1. It's also supported by a hyperplane with normal P2. And in fact, any positive linear combination of the two will also support it. So there's an entire wedge of normals for supporting hyperplanes. So a lot of this isn't too relevant since I'm running out of time. Whenever convenient, but I'm only going to talk for a couple more minutes, whenever convenient, I'm going to assume that that set of normals for supporting hyperplanes is as big and as multidimensional as I want. I actually don't need it to be as big as I want. I just want it not to shrink to 0 in size. Yes, 5 minutes. Yep. Okay, I also assume that more is better. So to translate this into stuff that's useful to, maybe stuff useful to you, there is a natural model in economics which has now been around for 60 years, but it didn't get really popular until the late 20th century. Aumann wrote this model, though, in the 1960s, which is effectively unanimity aggregation, where each candidate preference is defined by a probability distribution. So all this stuff is completely routine. There's a finite set of states. Every agent has a set of probabilities, which you may call credences. Here's a particular element of that set. An option is a savage act. It's just a delivery, say, of a quantity of money at every state. And you have a concave, the real numbers are showing up now. You have a concave utility for your Fundamental-Morgenstern utility function for your consumption at every state. And the unanimity preference just says that your expected utility for X is bigger than the expected utility for Y, no matter which probability you use to calculate expected utilities. So that is a special case. From my point of view, it's not particularly interesting. The only thing that's important about it is that it gives us a kink. So any story you want, as long as it gives the multiplicity of supporting hyperplanes, will do for what makes this interesting in economics. So there are a couple applications of this. There's an entire, which might appeal to you, there's an entire body of theory about how to complete these incomplete preferences, not on the argument that it leaves you manipulation free, but on other grounds that I won't have a chance of get to. There are a couple applications that I think are interesting. It's the subject of about half the book I wrote, are examples like these, is that there are two things that are unnerving about incompleteness as I defined it, were the crucial feature of those multiplicity of supporting hyperplanes. The first is that there's going to be a lot of optima. So when you have complete intransitive preferences, under mild assumptions, a little bit of continuity, a little bit of increasingness, the set of points where you're indifferent has lower dimension than the dimension of all the sets of possible options. So if they're L goods, there's an indifferent surface is going to be an L minus one dimensional set. You're almost never going to come across two options that are indifferent. So economists love this fact. Economics gives answers. And with incomplete preferences, this is no longer true. If this is returning to the bow tie picture, if X and Y are tied in some sense, then they're going to be robustly tied, because you can improve, remember more is better now, if you can improve Y by giving this person more of both goods, if Y is an unranked relative to X, as it is in this picture, and it's not on the boundary, then so is Z, even though Z is an improvement. So this being tied, or the lack of having a unique optimum, is a robust phenomenon. 2 minutes. Okay, so I'll just finish this so there's another application that says that indifference becomes a very, very rare event that I won't get to. Let me just finish with this 2 pictures. So what was a little vague about what I just said was that I said, well, you're never tied, but it would be better to be explicit about what are the feasible set of things you can choose from. So F is a feasible set of bundles. This is one of these kinked better than sets. And I call an optimum, so what does it mean to be an optimum? It means there's nothing that dominates it from the feasible set. So I'm going to call X a regular optimum if a couple properties hold. Basically, the 2 properties. One is that there is this separating hyperplane that separates the feasible points from the preferred points. That's really the part of the definition of what an optimum is. It has an interpretation as in terms of profit maximization. And the other is that the P here that is the normal to the separating hyperplane lies in the interior of the set of normals of the entire set of hyperplanes that support B of x. And the significance of the latter fact, I'm in my last sentence, and I'm terrified that you're going to start clapping or something. In my last sentence, the openness of the set of regular optimum, you can see in this picture, as we move to from x to a nearby x prime, if you assume that these better than sets only change very slowly, or more accurately, that the sets of supporting hyperplanes only change very slowly, if you start at a regular optimum, you'll after a small enough move, you'll still be at a regular optimum. So you're undermining the thing that is most dear to economists, that they can walk into a room of policymakers and tell them what to do. So you're not going to get a bottom line judgment out of for an agent like that.